Good morning, students. So today we are going to discuss last two topics of unit 3. Okay. So here we will be discussing about electro-refining and corrosion. Now, first of all, what is refining? Okay, now see, the metal produced by various reduction processes are not pure. Okay, we discussed before this that how we can extract metal from its ore. So whenever we extract metal from its ore, then it is not in pure state. There are so many impurities. Okay, so they contain impurities which needs to be removed from the metal so that we obtain the pure metal. Now this process is called refining. Now a very important refining process is electrolytic refining. Now electrolytic refining, just the name, as the name suggests, there is use of electrolyte. There is use of electrolyte. Now what is electrolyte? Electrolyte is a substance which conducts electricity in its molten state or in its aqueous solution. Okay, just like sodium chloride is an electrolyte. So when it is electrolyte, when we will take its molten state or we will take its aqueous solution. Okay, so electrolytic refining, what is electrolytic refining and how we refine a particular metal by this process, this we will study. Now many metals such as copper, zinc, tin, nickel, silver, gold, they are refined by electrolytic refining. Now what is the process? In this process, impure metal is made anode, okay, and thin strip of pure metal is made cathode. Now see, anode whichever is taken, that is very thick because it contains impurities, and we have to take cathode which will be very thin strip of pure metal. Okay, now solution of the metal salt is used as an electrolyte. Now see, what is electrolyte? Electrolyte is such substance which contains those ions which metal is to be purified. Suppose I am purifying copper metal, then my electrolyte must contain copper ions. Okay, then only this process will occur. Now what happens in this process? When we connect the whole apparatus, then after passing the current through the electrolyte, what happens? Pure metal from the anode dissolves into the electrolyte. Okay, whatever impure rod we have taken which is made as anode, metal atoms will come from that anode and they will get dissolved in the electrolyte. Okay, now an equivalent amount of the pure metal. Now since that electrolyte contains ions of that metal, so as many atoms have come into electrolytic solution, that many ions from the electrolytic solution will go and they will start depositing on the cathode. Now this process will continue. Okay, this process will continue, and whole of the atoms which are present at the anode, they will come into solution first, and then from the solution they will deposit on the cathode. Okay, now whatever impurities are there, they will be of two types, soluble and insoluble. Soluble impurities will go into the solution, and insoluble impurities will settle down at the bottom near the anode, and that is known as anode mud. Okay, so this way we do it. Now let us understand this by diagram. Okay, now see what we have done. This is anode, this is anode, and this is impure. Okay, this is impure. Now this is cathode and this is pure. Now what is anode? Anode is that particular rod which is connected to positive terminal of the battery, and cathode is that which is connected to negative terminal of the battery. Now here we have taken copper sulfate solution, it is blue in color, so we have added little amount of acid also. Okay, then it conducts properly. Now when the process starts, when we start the current, when we allow current to pass in it, then what happens? Copper atoms which are present in anode, they will come from this in the solution. Okay, in the solution there is presence of copper ions. Okay, so as many atoms have come into this solution as ions, that many ions will move from this and they will deposit at the cathode. So with the passage of time, the anode will start decreasing, its concentration will decrease, it will become thinner and thinner, whereas the copper gets deposited on the cathode, and so its thickness will keep on increasing with the passage of time. Okay, so this is the process which occurs. Now those things which are impurities, and are present here, what will happen to those impurities? Those impurities will settle down at the bottom. Okay, these impurities will settle down at the bottom and they will be termed as anode mud. Okay, and in case there is some soluble impurity, then that will remain in this solution. Okay, soluble impurities will remain in this solution. Okay, now this is the process of electrolytic refining. Now we come to last topic, it is corrosion. Now definition of corrosion was done in the beginning also. Okay, so corrosion, what is corrosion? The process of deterioration of a metal by the action of atmospheric factors. What are atmospheric factors? Air is there, moisture is there, some dissolved gases are there like carbon dioxide. Sometimes there is presence of acid also in the form of acid rain. Okay, so all these factors, they are responsible for deterioration of metal, and that deterioration of metal is called as corrosion. Okay, now let us take few examples. Sometimes they are asked also. Now if we take this silver spoon and if we keep it exposed in the air, then in the air it gets moisture and oxygen, so there is formation of silver sulfide. Okay, silver sulfide gets deposited and it becomes like this. So because of this, its color becomes black. Okay, its shining metallic luster is lost and it becomes black. So this black color is because of the presence of silver sulfide, which is formed by the action of silver with atmospheric gases like sulfur dioxide, etc. Okay, now second thing, in case of copper, it reacts with carbon dioxide in the presence of moisture, and then it remains, it forms a green layer of copper carbonate. So you can see when there is some copper vessel, then we may see little green thing deposited on the surface. That green thing is copper carbonate. Okay, now how it is formed? By the action of copper with carbon dioxide, which is present in the air. Similarly, this is iron nail and this is the nail with rust. So this rust gives rise to, this rust is a brown substance. Okay, its formula is Fe2O3 dot X molecules of water. So these all things are formed because of action of metal with atmospheric factors. Now let us understand first which conditions are required for rust to form on iron. So we will understand it with the help of a little activity, with a small activity. We will take 3 test tubes A, B, C, and we will put water in the first test tube, and we will put nails in all the 3 test tubes first, and in the test tube 1 or A we will put only water, and then we will cork it, and it will be like this, that there is presence of air also on the top, and those nails are half dipped in water and half are in open. Okay, now what we do in the second test tube where nails are there, we will add 1 ml of oil and then we will add boiled distilled water. Boiled distilled water is taken so as to give oxygen out from water. Okay, sometime what happens, because of atmospheric pressure, there is little amount of oxygen which is present as dissolved oxygen in water. So when we boil, then those air molecules, they go out. Okay, so because of that there is absence of air. Okay, now when we will do this, that we will add boiled water and then we will add 1 ml of oil, then what will happen, those nails will be completely merged in water and a layer of oil will be on the top. This oil layer is to prevent the presence of oxygen or to not allow oxygen to get dissolved in water. Okay, and in third test tube what we will do, we have taken nails, in that we will just add anhydrous calcium chloride. So what is anhydrous calcium chloride role? Its role is to absorb the moisture present in air. We will airtight these all and then we will see that where we can see the rust. Okay, now from this diagram you can see here our nails are in contact with air also and with water also. Okay, in this case they are in contact with only water. Air is not at all there because we have taken boiled water and dissolved oxygen is taken out, and then there is a layer of oil which does not permit oxygen to get dissolved in water, so it is presence of only water. And in this case there is presence of only air which is dry. Why dry? Because anhydrous calcium chloride absorbs all the moisture. Now after some time if we will see, then we will find rust only in this case. There will be no rust when only water is there. There will be no rust when only air is there, which is dry. So what we observe, or what is our result is that rust can only be formed if there is presence of air as well as moisture. So both things are required. If only one is available, then there is no formation of rust. Now how can we prevent rusting, or how can we prevent corrosion? So there are so many methods: painting, oiling, greasing, galvanizing, chrome plating, anodizing, and making alloys. Making alloys is also termed as alloying. The process of converting a substance into an alloy is called alloying. Okay, now what is galvanization? Galvanization is the method of protecting steel and iron from rusting by coating them with a thin layer of zinc. So what we do in galvanization, we take iron article and then we place a layer of zinc over that. Zinc is more reactive than iron, so what happens, it reacts with atmospheric factors and first it gets spoiled and it protects the iron. Okay, now what is an alloy? This we have done earlier also. So what is an alloy? Alloy is a homogeneous mixture of two or more metals, or a metal and a non-metal. Okay, it is prepared by first melting the primary metal and then dissolving the other element in it in definite proportion. Okay, it is then cooled to room temperature. So what we do when we have to prepare an alloy, then its all components should be taken in which state? In liquid state. Then they should be mixed and then the mixture should be taken in the room temperature. Okay, now alloying is a very good method of improving the properties of a metal. It is a wonderful method. Because of this we can get desired changes in the properties of metal. For example, see, iron which is mostly used in metals. Okay, it is never used in the pure state. Why it is not used in pure state? Because if we take it 100% pure, then it is not a very hard, it is soft, and when increase in temperature occurs, then it may stretch also. Okay, but what we do, if we mix it with a small amount of carbon, how much carbon? About 0.05%. If we mix it with 0.05% carbon, then it becomes hard also and strong also. Okay, now when iron is mixed with nickel and chromium, then we get stainless steel. Okay, there are so many uses of stainless steel. So how we get stainless steel from iron? Iron is mixed with nickel and chromium and it converts into stainless steel. Okay, so if we mix iron with some other substances, then its properties also change. Okay, now in fact the properties of any metal can be changed if it is mixed with some other substance. Okay, so this was all about alloying. Now see here, you can see this diagram is for the formation of alloys. This is for the formation of alloys. So here what we are doing, you can see in this diagram, we have taken our elements which are to be mixed in molten state, and then they will be cooled to its room temperature, and then they will be used as alloy. Okay, now one more thing is there which is called amalgam. What is amalgam? If one of the metal is mercury, then that alloy will be termed as amalgam. So in other words, we can say when we take a metal with mercury, it is termed as amalgam. Okay, now brass is an alloy of copper and zinc. Bronze is an alloy of copper and tin. They are not good conductors. So what does it mean? If we take only copper, then it is a very good conductor and it is used for making electrical circuits. But if we are mixing it with some other substance, then it is not retaining its property. So it means alloys, when they are formed, their properties change. Okay, now a very important alloy is solder. You might have seen when there is some problem in electrical circuits, if some electrical circuit breaks, there is connection problem, then what we do, we take a particular alloy which is called solder, we melt it and then we apply it, and it is used for welding electrical wires. Okay, so it has very low melting point and it is very useful. It is an alloy of lead and tin. So solder is an alloy of lead and tin. So this you can remember. Now coming to last, two things are left now. One is, what do we mean by 24 karat gold? What is the meaning of 24 karat gold? Now see, 24 karat gold means that it is 100% pure gold. But gold is a soft metal, so we cannot use it as 100% pure. Why? Because if we will keep it in the sun, then its shape will slowly start changing because of its melting. Okay, so what we have to do, we have to mix it with other substances so that it becomes hard and its melting point also increases. So what we use 22 karat gold mostly. So what does it mean? It means that we have taken 22 parts of pure gold and we have mixed 2 parts of any other substance. It may be copper or it may be silver. Okay, so in case what I do, I take 20 parts of pure gold and 4 parts of any other substance like copper or silver are mixed, then that will become 20 karat gold. If I take 23 parts of gold, pure gold, and only 1 part of copper or silver I mix, then it becomes 23 karat gold. Okay, so mostly we use 22 karat gold. Now one more example of this alloy is that in Delhi at Qutub Minar there is an iron pillar. That pillar is there from 400 BC, and we have not seen any decay in that pillar, and that is made up of iron. There is iron is one of the component of that particular alloy. So it means that alloying makes the metal so strong that it can stay up to so many years as it is. Okay, so here there is formation of, now why is it so? This is likely because of the formation of a thin film of magnetic oxide on the surface as a result of finishing treatment given to the pillar, painting it with a mixture of different salts, then heating and quenching. The iron pillar is 8 meter high. Okay, now see what they have told here. Here the reason of not getting rusted is told. Okay, so just like there is a protective layer of aluminum oxide in aluminum, here also they have developed by so many methods a protective layer which is protecting this pillar from weather conditions. Okay, so you can well judge that how much our these techniques were developed at old time also. Okay, so this particular pillar is 8 meter high and it weighs 6 tons. Its weight is around 6000 kilograms, so it is very high. Okay, so what is to be learned from this? We have to just learn that this is made up of an alloy, and alloy strengthens our metal by changing its properties. Okay, so alloys are very much useful. This is to be learned from this. Okay, now whatever we have discussed, on the basis of that you have to solve these home assignments. Okay, thank you.